Hello everyone, in this video we will solve GATE Physics 2022 question number 21. From the pairs of operators given below, identify the ones which commute. Here L and J correspond to the orbital angular momentum and the total angular momentum respectively. So in this question we will have to identify which pairs of operators commutes. So more than one option can be correct here. So L here represents orbital angular momentum and J is the total angular momentum. So definitely J would be L plus S. S is the spin angular momentum. So J square is L plus S square, that is L square plus S square plus 2L dot S. Now the first option is commutator of L square and J square. So L square and J square is equal to L square plus S square plus 2L dot S. So we can write this as separately, so L square and commutator of L square plus L square S square plus 2 is outside as it is a constant, L square comma L dot S. Now L dot S can be written as Lx Sx plus Ly Sy plus Lz Sz. Yes. So this is obviously 0 because it's the commutator of the same operators, and we know that L and S are independent to each other, so this commutator is also going to be 0. So this and these are 0. So we are left with 2, and here we have L square Lx Sx plus L square Ly Sy plus L square Lz Sz. So we already know that L and S are completely independent to each other, so they will obviously commute with each other. So we are only concerned with this operator, that is L square Lx, and Sx is outside because Sx is just will act as a constant here because it does not commute with, it commutes with L any component of L plus L square Lz and Sz. We also know this property that L square and Li, L square with any component of L is going to be 0 where I belongs to X, Y and Z. So using this we can definitely say that all of these commutators are going to be 0. So finally we get here, from here we get that this is equal to 0. So the option A is correct because L square and J square commute with each other. Now option B is commutator of J square and Jz. J square with Jz. So this can be written as J square is L square plus A square, or that need not be written out. So we know that L square commutating with Lz. Similarly, A square commutes with Sz. So this commutator is 0 and this commutator is also 0. And we this applies to J square as well. So J square with any component of J is 0. So J square Jz is also equal to 0. Or you can separately show it out by J square, by written out J square as L square plus S square plus 2 L dot S and Jz. So Jz is definitely Lz plus Sz. So you need to show from here. Now L square will commute with Lz as well as Sz because L and S are completely independent to each other, and A square is also commuting with Lz and Sz. So we need to show that these two LZ SZ plus LY SY. Sorry, we need to start with LXX. So LXSX plus LYSY plus LZ SZ, comma LZ plus SZ. So 2 is outside. We can write out two different. 2 is on there, so we'll write it at the end of this calculation. So LXSX with LZ and then also with SZ. So we'll have LX LZ SX is there because LX always will commute with S6 and LZ, any component of L will commute with any component of S, so SX is outside. Similarly SY, so LY LZ SI plus LZ LZ SZ. We will have 6 more terms from here. SX SZ plus LY SY SZ plus LZ SZ SZ. Now these two terms are 0 definitely, so we still have 4 more terms. So LX LZ, we know this operator relations, so minus a I H bar LY SX plus I H bar, this is I H bar LX SY. From here we get LX and SX SZ is minus I H bar SY. So minus I H bar is there, so this sign is minus I H bar LX and SX SZ is SY. And SY SZ is plus I H bar SX, so plus I H bar LY SX. So minus I H bar LY LX and my plus I H bar LY LX, these two gets cancels out and these two gets cancels out, so this is 0. So we have proved that L square Z square is J square is also commutes with JZ. So these are all, this option is also correct. Now option C, that is J square with LZ. J square with LZ. So J square is L square plus S square plus 2L dot S comma LZ. Basically we have done this calculation in this option because this LZ was there. We have done extra calculation with SZ, so we have this the first two terms is there, so we don't need to calculate it. We have the result. So L square will commute with LZ, A square is also commute with LZ, so we have L dot S, which is LX SX plus LY SY plus LZ SZ and LZ. So basically we have done this calculation in this option. So what we got is minus I H bar LY SX and plus I H bar LX SY. So 2 minus I H bar LY SX plus I H bar LX SY. That is what we have got, plus I H bar LX SY. Yes. So this is definitely not equal to 0. So option C is not correct. So this two does not commute, and we are left with only option D. So in option D we have to find out the commutator relation of LZ with JZ. So LZ and JZ can be written as LZ plus SZ. So LZ will definitely commute with LZ, and LZ and SZ will also commute because these two are independent to each other. So this is equal to 0. So option D is also correct. So these three pairs commutes with each other. So the right answer for this question is A, B and D. These three answers. Thank you.